Hi students, my name is Ratnaprabha Patil. Today we are going to continue with your topic electrostatics. In last lecture we have discussed about electrical energy of 2-point charges and of a dipole in an electrostatic field, along with discussion of or some introduction of potential energy of the system, that is electrostatic potential energy. So in that a point you have studied, that is equation of potential energy when a system of 2-point charges, means potential energy of system of 2-point charges. Now we are going to continue with B point from your syllabus, which is potential energy of system of n point charges, which is the continuation of, you can say, in A point. That is, in A point you have studied potential energy of system of 2-point charges. The equation which we have got, that is U, which is potential energy, is equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R12. Here Q1 is one charge which is placed at point A, Q2 is another charge which is placed at point B, and R12 is the position vector, or you can say distance between charges Q1 and Q2. This equation we are going to use now. We are going to study potential energy of system of n point charges. So here in first point what we have did, that charges Q1 and Q2 we have kept apart, that is they are having infinite distance in between, means they are separated infinitely, and we have displaced that charges, that is Q1 from infinity to point A and Q2 from infinity to point B, which are separated by distance R1 from origin and R2, that is R1 is separated, Q1 is separated by distance R1 from point O, and Q2 is separated by distance R2 from origin, and Q1 and Q2 are separated by distance R12, that is position vector in between charges Q1 and Q2. Same thing we are going to continue, and we are going to find out the potential energy of system of n point charges. So here before that we have displaced two charges Q1 and Q2. Along with that we are going to displace, or we are going to bring a charge Q3 from infinity to point C, which is at distance R3, or its position vector is R3, and work we done is against the electrostatic force between both, that is Q1 and Q2. सो आप इस फिगर में देख सकते हो, आपको क्या करना है, और एक Q3 चार्ज लेना है, and we are again displacing that Q3 charge from infinity near to the charges Q1 and Q2, and it is separated by distance r3 from origin to point C, which is given, right? So work done क्या होगा? Work done is equal to potential at C due to Q1 and Q2 into Q3. So this equation you have studied what is work done. So we can write it that 1 upon 4 pi epsilon naught Q1 divided by R13 plus Q2 divided by R23 into Q3. R13 क्या होगा? Distance between charge Q1 and Q3. R23 क्या होगा? Distance between charge Q2 and Q3 multiplied by charge itself, that is Q3. तो आपको इस इक्वेशन को सिंप्लीफाई करना है, दैट इज 1 अपॉन 4 पाई इप्सिलॉन नॉट Q1 Q3 डिवाइडेड बाय R13 प्लस Q2 Q3 डिवाइडेड बाय R23. सिमिलरली जैसे आपने Q3 को इन्फिनिटी से पॉइंट C तक लेके आए आप, वैसे भी आप क्या कर सकते हो, चार्ज Q4 फ्रॉम इन्फिनिटी टू डिस्टेंस D. तो उसका पोजीशन वेक्टर क्या होगा? फ्रॉम ओरिजिन R4 एंड वर्क डन होगा W4 विच इज इक्वल टू, that is against electrostatic forces of Q1, Q2 and Q3. So W4 is equal to 1 upon 4 pi epsilon naught Q1 Q4 divided by R14, which is the distance between charges Q1 and Q4, plus Q2 Q4 divided by R24, that is distance between the charges Q2 and Q4. Similarly, plus Q3 Q4 divided by R34. So if you are doing it for n number of charges, so आपको क्या करना पड़ेगा? Instead of writing this bracketed equation, you can write summation directly. So this will be your equation, that is U is equal to 1 upon 4 pi epsilon naught summation of all the pairs, that is Qj, which is starting from Qj to Qk divided by Rjk. This will be your equation of potential energy for a system of n point charges. Okay. Now we are going to discuss C point from electrical energy of 2-point charges and a dipole in an electric field. So here potential energy of single charge in an external field, this point we are going to discuss. In earlier 2 points, that is A and P, we have obtained equation of potential energy, or you can say expression of potential energy of system of charges where source of electric field and their locations are specified. मतलब charges and their locations are specified, R12, R1, R2, R3. These distances we have took, or position vectors we have took to specify the distance between charges and their location. Now we are going to determine the potential energy of a charge or charges in an external electric field, that is E, which is not produced by the given charge or charges. मतलब आप कोई भी चार्ज ले लो Q1, Q2, Q, Due to that, आपको यहाँ पे क्या करना है, इफ चार्ज इज प्लेस्ड इन एक्सटर्नल इलेक्ट्रिक फील्ड देन व्हाट विल बी द पोटेंशियल एनर्जी ऑफ दैट charge, that we are going to find, that not due to that charge. Okay, so if E is an electric field of given source and V is its electrostatic potential due to external source, मतलब एक पॉइंट चार्ज लिया आपने, we have placed it in an external electric field, so E क्या होगा, E is the electric field of that external source and V is the potential due to external source. Then if VR is the external potential at any point P having position vector R. So if we have placed one charge in an external electric field, then we have considered one point P where external potential at any point P from position vector R is what, VR. Now work done in bringing a charge Q from infinity to given point in an external field is Q into VR, that is Q into potential of that point. Means आपने क्या किया, external field ली, in that we are going to bring one charge Q from infinity to some distance, that is R. तो उसका वर्क डन क्या होगा, Q into VR. R is the position vector, right? This work done is stored in the form of potential energy of charge Q. Hence, potential energy of system of single charge Q at R in an external field is given by PE is equal to Q into VR. That is, we have took one external source which is having electric field E, potential VR और potential is V. बाद में आपने क्या किया, एक चार्ज Q लिया, उसको क्या किया आपने, वो इलेक्ट्रिक फील्ड का जो सोर्स है, सोर्स से बहुत ज़्यादा दूर है, दैट इज़ इनफाइनाइट डिस्टेंस पे है, तो आप चार्ज Q को एक फाइनाइट डिस्टेंस R पे लेके आए, तब उसका वर्क डन कितना होगा, Q इंटू VR, दैट इज पोजीशन वेक्टर बिटवीन टू. तो पोटेंशियल एनर्जी क्या होगी, दैट इज PE इज इक्वल टू Q इंटू VR. Okay. In continuation with point C, we are going to discuss point D, that is potential energy of a system of two charges in an external field. In first point C, we have took a single point charge. Now we are going to take two charges, that is Q1 and Q2. Same thing we are going to do, that is we are going to take, or we are going to consider one source which is having electric field E and it is having some potential V. So in that we are going to consider system of two charges, that is Q1 and Q2, located at R1 and R2 respectively in an external field. Now work done in bringing the charge Q1 from infinity to R1 in an external field is Q1 VR1, which we have discussed here. That is, work done क्या होगा, Q into VR. Here only one single charge we have took, so there is a Q into VR. Right now we are going to take two charges, so Q1 VR वन। मतलब Q1 चार्ज पहले इनफाइनाइट डिस्टेंस पे था फ्रॉम इलेक्ट्रिक और एक्सटर्नल इलेक्ट्रिक फील्ड, तो आपने क्या किया, वी हैव डिस्प्लेस्ड दैट चार्ज Q1 फ्रॉम इन्फिनिटी टू डिस्टेंस R1 इन एंड दैट एक्सटर्नल इलेक्ट्रिक फील्ड। सो उसका वर्क डन क्या होगा, Q1 VR1। नाउ to bring charge Q2 to R2, the work done is against external field as well as the field due to Q1। ठीक है, पहले क्या था, दोनों चार्जेस Q1 Q2 both are at infinite distance from the external electric field। बाद में आपने क्या किया, Q1 को डिस्प्लेस किया एंड वी हैव टुक दैट चार्ज एट पॉइंट वेयर एट पोजीशन वेक्टर R1। तभी R2 भी क्या था, इन्फिनिटी पे था। तो जब R2 को आप इन्फिनिटी से एक्सटर्नल इलेक्ट्रिक फील्ड के R2 डिस्टेंस तक लेके आओगे, तब उस Q2 पे दो फोर्सेस या फिर Q2 को हमें Q2 को लाने के लिए वर्क डन जो करना पड़ेगा वो क्या होगा, अगेंस्ट एक्सटर्नल फील्ड एज वेल एज अगेंस्ट द फील्ड ड्यू टू चार्ज Q2। तो मतलब उसका एक्सटर्नल इलेक्ट्रिक फील्ड Q2 पे एक्सटर्नल इलेक्ट्रिक फील्ड का भी इन्फ्लुएंस होगा एज वेल एज influence of charge Q2. Now, so work done on Q2 against external field is Q2 into VR2, and work done on Q2 against the field of Q1 क्या होगा, Q1 Q2 divided by 4 pi epsilon naught R12 which we have finded out before। So R12 क्या है, distance between Q1 and Q2। So by the superposition principle, work done in bringing Q2 to R2 is equal to Q2 V R2 plus Q1 Q2 divided by 4 pi epsilon naught R12। So total work done in assembling the configuration is equal to, so if we have considered system of two charges in an external field, तो उसकी potential energy क्या होगी, Q1 V R1 plus Q2 V R2 plus Q1 Q2 divided by 4 pi epsilon naught R12। Now we are going to continue with the E point, which is potential energy of dipole in an external field. What is meant by dipole? We have discussed before also. Now what we have did, we are considering a dipole that is charge minus Q and plus Q. Consider a dipole with charges minus Q and plus Q separated by finite distance 2L placed in a uniform electric field E। तो आपका E का डायरेक्शन भी दिख रहा है, राइट। Q1 डाइपोल लिया आपने प्लस Q और माइनस Q चार्ज का, प्लस Q और माइनस Q चार्ज में डिस्टेंस कितना है, सेपरेटेड बाय डिस्टेंस 2L। It experiences a torque which tends to rotate it। तो क्या होगा, आपने एक टॉर्क रखा, डाइपोल रखा एंड डाइपोल और इलेक्ट्रिक फील्ड का डायरेक्शन देखो, आप यहाँ पे क्या दिख रहा है, एंगल थीटा दिख रहा है। तो क्या होगा, इफ आपने ये डाइपोल लिया और उसको आपने इलेक्ट्रिक फील्ड प्रोवाइड की, तो क्या होगा, दैट इलेक्ट्रिक फील्ड टेंड टू रोटेट ड्यू टू इन्फ्लुएंस ऑफ इलेक्ट्रिक फील्ड। वो डाइपोल क्या होगा, रोटेट होगा, और उसका टॉर्क कितना होगा, टो इज इक्वल टू पी इंटू पी क्रॉस ई, और यू कैन से टो इज इक्वल टू टी ई साइन थीटा। यहाँ पे क्या है, पी क्या है, डाइपोल मोमेंट। So this dipole is going to rotate when electric field is applied। तो आपको वो जो टॉर्क है जो रोटेशन की वजह से प्रोड्यूस हुआ है, वो आपको क्या करना है, न्यूट्रलाइज करना है। सो आपने क्या किया, टॉर्क टो एक्सटर्नल आपने क्या किया, यहाँ पे अप्लाई किया, एंड ड्यू टू दैट जो टॉर्क प्रोड्यूस हुआ था ड्यू टू एप्लीकेशन ऑफ एक्सटर्नल इलेक्ट्रिक फील्ड, वो न्यूट्रलाइज होगा। जो हमने टॉर्क अप्लाई किया था, इट इज इन द प्लेन ऑफ पेपर फ्रॉम एंगल थीटा 0 to angle theta without angular acceleration, and work done by external torque is given by equation integration of theta 0 to theta to external theta into d theta। okay, so आपने पहले क्या किया, we have took one dipole, after that to that dipole we have applied external electric field. Due to that external electric field, the dipole is going to rotate. Due to that rotation, torque is produced. Okay, to neutralize the torque which is produced due to application of electric field, we have applied, or we have applied external torque T external, which rotates in the plane of paper from angle theta 0 to theta, and due to this the torque which is produced due to external electric field is get neutralized, and the work done by the external torque is given by equation W is equal to theta 0 into theta 0 to theta T external theta d theta। तो आपने टो का इक्वेशन अगर न्यूट्रलाइज कर रहा है, तो जो एक्सटर्नल इलेक्ट्रिक फील्ड अप्लाई करने से जो टॉर्क प्रोड्यूस हुआ और जो हमने अप्लाई किया उसका मैग्नीट्यूड सेम होगा, दैट इज पी ई sin theta d theta। After solving this integration, what we have got, PE into bracket cos theta 0 minus cos theta, which is the work done. This PE into bracket cos theta 0 minus cos theta, this is what work done, and this work done is stored in the form of potential energy of the system in the position when dipole makes an angle theta with the electric field. So, zero potential energy can be chosen as per our convenience. So, what we choose, u theta minus u theta 0 is equal to PE in bracket cos theta 0 minus cos theta. In at initial state, if dipole is perpendicular to the field E, तो थीटा 0 क्या होगा? पाई बाय 2. देन u थीटा क्या होगा? पी ई कॉस पाई बाय 2 माइनस कॉस थीटा विच इज इक्वल टू माइनस पी ई कॉस थीटा. हमने वेक्टर पढ़ा है तो u थीटा क्या होगा? माइनस पी डॉट ई. ये क्या है? P डॉट इज द डॉट प्रोडक्ट. सो डॉट प्रोडक्ट क्या होता है? पी ई कॉस थीटा. And if initially dipole is parallel to the field, theta 0 is equal to 0. So PE cos 0 minus cos theta, तो cos 0 की वैल्यू क्या होती है? 1. सो आपका पोटेंशियल एनर्जी का इक्वेशन क्या आएगा? PE in bracket 1 minus cos theta. So this is all about the your lecture. From in next lecture we are going to take dielectrics and electric polarization. The point 8.7, that is conductor and insulator, free charges and bond charges inside the conductor. This point 8.7 is not included in your syllabus for this batch, that is 2020-21. Thank you.